So network covalent atomic solids. Carbon is a really important one. So there's several different types of carbon, several different forms of elemental carbon. They're called allotropes. One of them is graphite. That's what's in your pencil lead, right? Graphite has sheets, layers of carbon atoms that are covalently bonded to each other in little hexagonal rings. You can see one here. It's a hexagonal ring. But the layers are held together by dispersion forces. So those are very weak. So that makes these layers really slippery, and that's why it's a good electrical conductor and it's a good pencil marking tool, because as you slide your pencil on the paper, parts of the graphite slide off, right? A diamond is also pure gold. I'm sorry. I think I'm losing it. Okay. I might edit that out. That was, okay. A diamond is also pure carbon, just like graphite. But it has a larger density, and the atoms are now closer together. Here they are bonded together covalently in all three dimensions. So that makes the diamond very strong and also have a really high melting point. So the diamond unit cell is similar to that zinc blend cell, but we have carbon atoms in there. So high pressure favors the formation of diamond from graphite. What can you conclude about the relative densities of the two substances? So if you take graphite and you squish it, it makes a diamond. Is one more dense than the other? Yeah. The thing that you were squishing was the less dense, right? And the thing that you end up with after squishing it would be more dense, right? So a diamond is denser than graphite. There are other forms of carbon. This one was discovered, not invented, but discovered in the 1980s. This is called a Buckminster fullerene, or Bucky Balls for short. So here we have the carbon atoms forming these open spheres. They're shaped like a soccer ball. They can have different numbers of carbon atoms, as few as 36 or up to more than 100 carbon atoms, making one big soccer ball. You can also make tubes called nanotubes. So here we have graphene. And so you can make a graphene ribbon, or you can imagine, it kind of looks like chicken wire, doesn't it? What if you bend it around and attach it, you could get a tube. And this tube will conduct electricity and heat. And we can also have multi-walled, nested carbon nanotubes. So these are just crazy. But this is the sort of thing that they use, in expensive golf clubs and bicycles. It's got a carbon frame. Well, how does carbon make a strong frame? Well, when it's structured like this. Any questions? Here's the slide I should have gotten to. Silicate. Quartz is an example of silica. So the silicon is bonded to 4 oxygens. So why is the formula SiO2? Well, because each of these oxygens is also bonded to another silicon, right? So each of these is shared between 2 silicons. So essentially this silicon has half of 4, so it's Si2. There's different forms of this. This is the bulk of sand, is silica.